Bright Tuty. Every student matters.
Let's see what we have learned about polygons. So let's start with the first question here. It says examine whether the following are polygons. If any one amongst them is not, say why. So look at the first figure. I hope you do remember what we learned about polygons in one of the previous class. We learned that a polygon needs to be a closed shape. It needs to be made up only of line segments. Is that right? That's the only condition. And also the line segments shouldn't overlap each other, right? So these were the few things that we learned about polygons. Let's see. Let's apply that knowledge here. So in the first image, clearly we can see that the endpoints of the given coil, which is like a squared coil, they are not meeting each other. So this is not a closed shape. So definitely this is not a polygon. Why? Because this is not a closed shape. So this is the reason that we have given for not being a polygon, that this particular first shape is not a closed shape. Now the second one. So the second one is a polygon. So this is correct. It is a polygon. It is a closed shape made up entirely of line segments. Moving to the next one. This is not a polygon. Why? Because it is made up of curve. This is a circle entirely made up of curve. So it is not a polygon. Now the last one is also not a polygon. Why? Again, we can see here we have got a curve, and a curve is not welcome in a polygon. So because again here we have got a curve, so this is not a polygon. So the reason you will write is that here, because our polygon should only be made up of line segments, and clearly in this image we can see a curve, and thus this is not a polygon. Now let's see this one. Here we need to name these polygons, and it is also asking us to make one more example of each of these. So here the first one that we see, polygon is always named depending upon the number of sides it has got. So here in the first one we have got 1, 2, 3 and 4 sides. So what is the name of the shape which has got 4 sides? We call it a quadrilateral. Quadrilateral. So this is the name given to a shape made up of 4 sides, and they are asking you to draw another such shape. So let me just put an image of a quadrilateral. I'll just use the simplest one, that is a square. Okay, so this is another example of a quadrilateral. You can even draw a parallelogram, you can draw a trapezium, you can draw a rectangle, anything, right? Now the second image that we see, it is an 3-sided shape, which is a 3-sided figure. So what is it? It is a triangle, right? So this is a triangle. Let me put an image of a triangle here. So this is the image of a triangle, right? Now in the C part we have got 1, 2, 3, 4 and 5 sides, right? So what is the name given to a shape which is a polygon having 5 sides? Is pentagon. Pentagon. This is how we write pentagon. And in order to draw pentagon, I'll just quickly bring one shape which is a pentagon. Okay, so here is a pentagon. This is another shape that I've drawn. I have though drawn this using like the prior tools in here. If you want, you can draw your own, but it will be very rough if I'm drawing. You can just draw any shape. 1, 2, 3, 4, 5. This is also a pentagon that I've drawn. Okay, why? Because it has got 5 sides. Okay, it is closed. It is entirely made up of line segments. So this is also the correct answer. Now coming to D part, it has got 1, 2, 3, 4, 5, 6, 7 and 8 sides. So this is an octagon. This is an octagon. And again, how we can draw this? Let me just draw it with 1, 2, 3, 4, 5, 6, 7. Okay, just one more left. So 8. This is my octagon, and I have just drawn any shape You can also draw any shape that you want in order to draw an octagon. Okay, I hope this is clear. It was simple. Now moving ahead, here we need to draw a rough sketch of a regular hexagon connecting any three of its vertices. Draw a triangle. Identify the type of triangle you have drawn. Okay, so first of all, let me bring a regular hexagon in here. Okay, so this is a hexagon. I hope you remember what the word regular stands for. The word regular means that it needs to have all the sides equal and all the angles needs to be equal as well. So all the sides of this shape are equal here, and all the angles that are formed here in the interior of the shape, all of them are equal to each other. Okay, so this is a regular hexagon. Now what they want me to do is, I'll just erase all this not required. Okay, so what they want me to do is that I need to draw a triangle in this image, and it is saying that connecting any three of the vertices. So let me just draw here. So this is the diagonal that I have drawn. I hope you do remember that diagonal is formed when we join the point which is sitting next to the adjacent point. So here, if I have started from this particular point, so this is point A, I have started from this point. So say point B was sitting adjacent to it, so I have joined it to point C. Okay, so the triangle that we have obtained is triangle A, B, C, and they are asking us to identify the type of triangle that we have drawn. What do you think? What type of triangle do you think we have drawn? Clearly we know that this particular side is equal to this particular side. And do you remember how do we classify triangles based on their sides? Do you remember? This kind of triangle which has got two sides equal, we call them isosceles triangles. I hope you do remember classification based of triangles based on the sides. There were three different types. There was equilateral triangle, isosceles triangle, and a scalene triangle, right? So this one here, because it's two sides equal, so this one is isosceles. This is isosceles triangle. Okay, two sides equal, isosceles triangle. If none of the sides are equal, then it is scalene triangle. If all three sides are equal, it is equilateral triangle. Now coming to the fourth point. The fourth question says, draw a rough sketch of a regular octagon. Draw a rectangle by joining exactly four of its vertices of the octagon. So let us first draw here. I'll just put the shape of a octagon, and it needs to be a regular octagon. That means all the sides needs to be equal in length. So I hope this is a regular octagon. It has got 8 sides, right? And here we need to draw rectangle by joining 4 sides. So let's put an image of a rectangle in this, and I'm joining it. I'm drawing this particular rectangle by joining the 4 sides, as you can see clearly, right? So here we have got, say, A, B, C and D. So this is the name that I have given to this particular rectangle. So it is saying that draw rectangle 4 sides of the vertices. So we don't have to do anything else. Can you say that this particular image that I have drawn is a rectangle? Surely. Why? Because these two sides are parallel and equal. Also, these two sides that we see, they are parallel and equal to each other. Okay. So this is how you can draw a rectangle in an octagon. Moving forward here, this is the last question for today. A diagonal is a line. A diagonal is a line segment that joins any two vertices of a polygon and is not a side of a polygon. Draw a rough sketch of a pentagon and draw its diagonals. So let me just insert the image of a pentagon here. So this is a pentagon, and we are going to draw a rough sketch of pentagon, and we are going to draw its diagonals. I hope you remember how we used to draw the diagonals. So let's quickly get, okay, so from here, if I join this is the first diagonal. Now again I'll join the and till here. So this is also another diagonal. Now I'm left with few more sides. Let's join it. So again we have got, from this point I can join this. This is another diagonal here. Now let's draw another one from here to here. This is diagonal number 4, and I think we are just left with one more. Okay, so beautifully we have got 5 diagonals in here. So total, if I name it as A, B, C, D and E, let's name all the diagonals that we have drawn. We have drawn diagonal AC, we have got diagonal AD, then from B we have got diagonal BE, we have got diagonal BD, then from point C we have got diagonal AC, we have got diagonal CA, which we have already named as AC, so we can't repeat it again. So then we have got CE, so CE. Then from D we have got DB, we have already written BD here. Then we have got DA, we have already written DA here. Then from point E we have got EC, we have written CE, and here from EB we have written BE. So there are total 5 diagonals that are possible in a pentagon. If you see, you can draw any bigger, you can draw a hexagon and see how many diagonals are there. The answer is that if you are drawing it, make sure that you draw it correctly. You will get a total of 9 diagonals in a hexagon. Okay,